attractive element of this whole thing here. And if we look at air quality instrumentation, sort of benchtop instruments like the TEOM right here, we actually developed a device that essentially works as a TEOM, but is much smaller. Right? So you can see that clearly there is a potential for several orders of magnitude of reduction in size of these instruments, right? And so again, as we reduce these things in size, we can think about now, it's not a benchtop instrument, right? This is now a badge or something embedded into a cell phone that people carry around, okay? So first of all, it becomes portable, right? Now we have actually users carrying these things, and they're not really obstructed by, carrying a backpack or a vest or some kind of device. It's just a tiny badge, right? At the same time, we make it smaller, we're reducing the cost of this equipment, right? So it becomes much less expensive. When we talk about microfabrication, we're usually concerned about how things scale as we go down in scale, right? So we're looking at, say, a characteristic dimension, this is, for example, a side of a box, in this case it would be S. So the cost of these devices really scale with the cube of that characteristic dimension, right? So as we make it smaller, it becomes much less expensive. Turns out that the power that you would need also actually scales. In this case, it scales actually with the S to the fourth power, and that has to do with essentially the volume of air that you would have to pull through the instrument to get a comparable measurement, right? So if we might miniaturize it, first of all, it becomes portable, wearable, it costs less, and it also uses much less power. Okay? So of course, if we can do this, this would be really great. Okay? And then I already mentioned some applications.